Hello everyone, today I'm delighted to introduce our work Rb-PaStaNet, a few short human-object interaction detection based on rules and postdates. My presentation will be divided into 4 parts: introduction, related work, our approach, as well as the results and our conclusion. Our work is in the field of HOI detection, human-object interaction, which infers types of interactions through retrieving human and object locations. Intuitionally, HOI detection is strongly related to the human body and object understanding, facilitating behavior and activity understanding. Here in Figure 1, you can see the examples of HOI detection. The blue boxes mark the humans, while the green boxes mark the objects. Each green line links a person and an object involved in the labeled HOI class. Next, I will introduce some previous work strongly close to our work. As far as we know, Professor Lu first applied parse states to HOI detection. By tokenizing semantic space as a discrete set of parse states, they constructed a sort of basic descriptors based on the segmentation. Closer to our work, PhD student Li divided the human body into 10 natural parts and utilized their states as discretized parts semantics to represent activities. Figure 2 shows how it works. So PaStaNet was proposed to reason out the activities with part-level semantics. PaStaNet makes a great improvement and reaches the state-of-art in the both full and few-shot tasks. Despite that, as you can see in Figure 3, the MAP of one-shot set in the PaStaNet is still below 0.3. There is much room for improvement. So to tackle few-shot classes performance bottleneck, we propose Rb-PaStaNet, mainly focusing on few-shot HOI classes. Here is an example of our two labels. In order to improve performance in few-shot HOI classes, our method introduced human prior knowledge on 10 body parts to reinforce learning on these rare HOI classes. We conduct model training based on PaStaNet database. Then we perform manual annotations on body parts to make a decimal label. In our annotation, label 1 indicates a strong correlation, 0 indicates irrelevance. As for common classes, all parts are labeled 1. Then we average annotation from 3 authors as the decimal label. The average value is distributed between 0 and 1. Besides, to find a better rule, we map the resulting decimal label to the Boolean label, true if the decimal label is no less than 0.5 or false otherwise. In PaStaNet, all features will be initially input to a part relevance predictor, telling a body part's importance in an action. A certain attention is then generated. In our approach, we use new rule-based attention to replace old one and compute scores or cross-entropy loss. Following the settings and the metrics of PaStaNet, we've done some experiments to make comparison with PaStaNet results. The table shows that our model gets slight improvements on both real and full classes. Boolean and decimal versions of rule-based PaStaNet achieve 0.1 and 0.13 MAP improvements on real HOI classes. We noticed that Boolean version has improved non-real classes MAP by 0.22. We believe if we use more accurate and detailed rule, we can make better improvements. So much for the presentation, and thank you.